Hi, in this video we're going to talk about 12-2 some more. This is the last video in a series. I hope you watch the other ones first. But now we're going to take vectors into the third dimension. So, real quick, we're going to draw a little axis system, and I hope I get this right on the first try. More or less. So now position vectors in 3D are coming from 3D coordinates, right? So we're going to translate a 3D coordinate, which has an x, a y, and a z component, into a angle notation. And again, that shouldn't shock you at all. That one's pretty straightforward. The idea number one, though, it's really important to remember, we have new basis vectors. We have a new standard basis. We'll have I hat, and now you're tuning out because you're like, oh, well, it's the same. I hat has to have 3 coordinates now. J hat has to have 3 coordinates now. And the thing you probably did predict will have a K hat, which will have also 3 coordinates. So what are we thinking? I hat's going in the positive X direction. Remember, it's positive X, positive Y, positive Z. J hat's going in the Y direction, and K hat's going along the Z direction. So because there's 3 coordinates, we need 3 basis vectors, okay? And that means that, to use our notation from earlier, if we had V1, V2, V3, we could write that as V1 I hat plus V2 J hat plus V3 K hat. The only other thing that really is going to change here is that the size of V, we'll have to use the 3D distance formula. So it'll be all of the components squared and added together, and then you take the square root. So make sure you add all 3 components. The last thing I'm going to say is, again, note, a big note. Slope is hard to define. Actually, I'll say slope and angle are hard to define. At least with relationship to the, like, giving us one angle. One angle won't work out. Slope is hard to talk about. There's going to be a little ways to resurrect angle and slope, or at least angle between vectors. But this basically means, of all the systems we had, so the only way to tell parallel is to see if the vectors are scalar multiples. Okay? I'll do an example of that. Notice how we're not even going to draw the 3D vectors. They're going to look kind of wacky. I know my key, they look wacky already. Show A, which is I hat minus 2J hat plus 5K hat, is parallel to B. It's not like I forgot to write B. It's just gonna be, there's gonna be 2 parts here. Try to show it for B equal to 3, -6, 15. That's what we did in the last video. We're going to try to factor the GCF out. Be 1, -2, 5, which is just another way of writing 3A. So, parallel. Okay? Like I said, I'm going to throw one more at you. What if B was 1/3 I hat minus 2/3 J hat plus 5/3 K hat? Can you show it's parallel to A? Here I go. So for fraction ones like this, it's usually helpful to factor out the common denominator. And if I factor out a 1/3, I'm left with I hat minus 2j hat plus 5k hat, which again is 1/3 a. So they are parallel. All right. I will say, notice the parentheses. I could have said this in the last video or the video before. I'm using parentheses when I use IJK notation because there is no angle brackets. Okay, the angle brackets are necessary for the component notation up there in blue, but for IJK notation, we do not need angle brackets. Just gonna move along, do another example. If A equals -I plus 2j, and B equals 2, 3, -1, find 2a minus 3b, 2, the length of 3a, and 3, the length of -2b. Can you find these three? I'm going to start. 3, 2, 1. So 2a minus 3b. Just be careful. You probably want to translate it one way or the other. I'm going to translate them both into component notation just because I want to show you A is secretly has a third coordinate. What's the third coordinate of A? It's 0. Now, you may have been able to follow your nose anyway. If you translate B to IJK notation, it all works out just fine. What you would get here is -5. Nope. Oh boy. Student mistake. -8. 4 minus 9 is -5. And +3. The length of 3a would be the length of -3i plus 6j plus 0k. Does it really matter? Nope, not particularly. So it's the same old formula. 9 plus 36, which is root 45. -2b, the length of -4, -6, +2. Careful, did you remember to square all three components? 16, 36, 4, root 56. Easy peasy. If it's not making sense to you, make sure you try to contact me. I'll try to help you out. Find the position vector. We're just reviewing everything with lots of examples coming at you fast for the vector from A at point 210 to B at point 145. Nope, not brackets, parentheses. So these are two 3D coordinates. Can you find the position vector between them? Do you remember what that looked like? So if I write A to B, it has to go that way with that order, with that arrow. Brackets. 1 minus 2. It's B's coordinates minus A's coordinates. To do this in any other order is wrong. So -1, 3, 5. That's it. That's a position vector. Easy peasy. In component form. If you wrote it with I, J, and K, would it be all right? Yes. Yes, yes, yes. Let's do another one. Given v equals negative I hat plus 3j hat minus k hat, can you find a unit vector in the opposite direction of v? It's not question mark, period. This is what we talked about a couple videos ago. You should be able to do this now. Try it out. 3, 2, 1. The first thing I want to do is to find the unit vector in v's direction. You could reverse v first. You don't necessarily have to stick to the order on this one, but I'm recommending it. 1 plus 9 plus 1, the square root of 11. So the unit vector in v's direction would be v over the length of v, which is 1 over root 11 times this guy, times what you started with, times v. And so a unit vector in the opposite direction, we're going to multiply by -1. U hat would be -1 over root 11. And you could distribute that negative if you wanted to. I'm not going to lose any sleep over it. One more example, and then we are done. Short video. Knock on wood. All right. Find v. That should also sound familiar. Find v such that, or so that, the magnitude of v is going to be 2, and v has the same direction, so is parallel to, as w equal I hat minus 2j hat plus 3k hat. Do you remember how to do this? Try to check your notes, try to do it, try to see if you can do it from memory. 3, 2, 1. So if the last example we had to find the vector first. It was like 2a minus 3b or something like that. For this example, they tell us exactly the vector we want. So I don't have to find it, I just need to find its pure direction. How do I find the pure direction of w? So the first step I would do is to find the unit vector, like w divided by the length of w. To do that, I would need to find the length of w, which would be 1 plus 4 plus 9, or the square root of 14. And so the unit vector, the pure direction, would be 1 over root 14 times I hat minus 2j hat plus 3k hat. So again, the unit vector has a length of 1. So all I need to do now is to scale. And how do I scale it? I just want to multiply by the magnitude 2 up here, the start of the problem, to make sure the length is 2. We have a unit vector with length 1. We want the length to be 2, so we'll just multiply by 2. V equals 2 over root 14 times the rest of the components we already found. Please be careful that you don't double distribute. Some students multiply the coefficient on the outside as well as multiplying the coefficients on the inside. So that's it. That's all the videos we have on vectors. I know it was a lot, but as a consequence of keeping them short. Thanks for watching, and I'll see you in the next video where we'll start talking about 12.3. Thanks for watching. Have a nice day.